Good morning. Welcome to today's lesson on solving three-step equations. We've been going through this process fairly straightforward, solving one, two, now we're up to three-step equations. And we're going to actually see two different types of what the third step could typically be. And then in our next lesson, we'll see how to put those two steps together to make four-step equations, combining them with what we've already got. So I want to refresh our memory a little bit here that we've kind of been working using the inverse order of operations. That's that poor, sad me that perhaps you remember from our last lesson. And we're going to ignore the exponent for now. So I'm just going to erase it because we're just going to not do anything with that. What we're really going to be working with, we're going to do some things with that parentheses now. You can see that's going to be one of our things. And then these two things together, one of each, either a division and an addition or so on. The other thing that we also find ourselves having to do is to combine our like terms, which we did a few weeks ago. So I'm going to give you two examples, one of each of those scenarios where we have to do with one or the other. And then obviously when we get into our lesson on four-step equations, we're going to put that all together and we're going to do both. Now, there are other ways to do there's actually one other way to do a three-step equation that technically doesn't qualify as a three-step equation in a lot of people's books because they consider it one step broken into two parts, but I don't know what the difference there would be. So I'll come back to that one. I'll finish with that, I think, at the end. So let's look at this. We're going to solve this equation. 3x plus 40 minus 5x equals negative 2. Okay? So we've got a couple of things working here. First, we have multiple variables, but they're the same variable. They're not x and a y. They're not different. So we want to make sure that we understand all we have to do is combine them. And that's typically going to be our one of the first things we want to do. In fact, where would this fall in my my inverse order of operations? It would actually fall right here. Combine like terms. So I would throw that in right between the parentheses, after the parentheses, which again, remember, parentheses is telling us deal with this first, and then after that, the rest of the operations, subtraction, addition, division, multiplication, and eventually finally the exponent, which we'll see much later on. But this combine like terms step falls in between. Now, again, there are two ways that we can approach this. We can deal with the fact that we have a 3x and we have a minus 5x. Some of you can just see that as straight subtraction. But I know for a fact still some people kind of go like this. That's just the way their brain works, and they go 3x plus, and then they leapfrog over. And I want you to understand that one thing you can do is you can underline the sign in front of the number because it's part of the number. And if you're still not seeing it, we can put a little cheese on it. We've been doing that the last couple of days. We can keep this 40, we can switch this subtraction to addition, and we can change the 5x to its opposite, which would be negative 5x. It really was, when we looked at it before, when it was subtraction or we're combining. So we're still going to do 3x, and now we've got a positive plus negative 5x. So 3 or a 3x minus 5x, whichever is easier for you to understand, that's how I want you to approach the problem. Either way, that's going to get us a negative 2x. Everything else is going to stay the same. The plus 40 is still there. The negative equals and negative 2 is still there. So that's our first step, is combining the like terms. Okay? Our second step, now we're right into the heart here of the adding, subtracting, multiplying, and dividing. We're looking for one of these two, subtraction or addition. I still have some, so I'm going to be subtracting that 40 from both sides, and I get negative 2x equals negative 42. And then the last thing, again, dividing by that number next to the variable, and x equals, and a negative divided by a negative is a positive. Again, the rule there is if the signs are the same, you get a positive. If they're different, you get a negative. So multiplying or dividing, what are the signs? Are they the same, positive? Are they different, negative? It doesn't matter which one's on top or on the bottom. It doesn't matter what's dividing what or what's multiplying what. All that matters is, are they the same or are they different? But you can see very clearly that we did 3 steps here. We combined like terms. So step 1 was to combine like terms, CLT, I guess. Step 2 was to subtract, and step 3 was to divide. So there's our 3 steps, where the first step now is to combine like terms. And I know this always adds a level of complexity that's maybe a little more challenging, because you know, when you learned how to count, you go 1, 2, 3, and the next thing you learned was 4. Instead of learning that you went 4, 5, 6, and then suddenly came along and said, let's learn 3, 4, 5, 6. We'll learn the first step. We'll introduce a new first step. We're actually introducing a new second step, but maybe before a third and a fourth step. So this is what we're looking at. We're looking for like terms. And again, this is where we are, 3 steps. We'll go to more complicated in a moment, maybe tomorrow, maybe next lesson. But for right now, combine the like terms, add or subtract something, multiply or divide by something. Now that's one of the possible scenarios for a 3-step equation. Okay, it's one of the very likely ones. Okay, but it's not the only one. So what else could happen? Well, we could have something that involves a parentheses. And something that looks like this. Okay? And now our first step is very obvious. We've got ourselves parentheses right there at the beginning excuse me, of the inverse order of operations. That parentheses is telling me to do the distributive property. If you remember that, that's where we draw those little rainbows to remind us that we're going to multiply the number that is outside the parentheses times all of the numbers that are inside the parentheses. So that means 2 times 2x is going to be 4x. 2 times -1 is -2. And now we're right back down here. We're going to add 2 to both sides. And then we're going to divide both sides by 4. And we are going to reduce. We never leave fractions unreduced, but we don't need to turn it into a decimal. So 2/4 would be 1/2, and a negative divided by a positive, as we just said, the signs are different here, so the answer is going to be negative. When the signs are the same, it's going to be positive. Signs are different in this case, so my answer is going to be negative. Now, if you turned it into a decimal, I wouldn't be complaining. I wouldn't be upset by it, but it's usually turns out to be just extra work that's unnecessary. You do always have to reduce a fraction, but you should never have to turn a fraction into a decimal. There's almost never going to be a cause where you have to have a decimal and a fraction wouldn't cut it. And oftentimes turning it into a fraction into a decimal will result in a repetitive decimal. If you were to do this with 1/3, you'd get 0.333, and you don't want to deal with that because it's just a repeating decimal instead of a nice neat fraction like 1/2 is. So this one, we went distributive property, subtract, and then we divided. So very similar. Actually, sorry, we didn't subtract, we added. Very similar to the one right above it. And you can see there's a time when I might have to do both of these. Okay. Now, we'll save that for another day. Okay. But I do want to talk about at least one other possibility for what might translate to a 3-step equation. And that is, you'll almost never see addition and subtraction at the same time. In fact, if you see addition and subtraction, really what you're going to end up doing is combining like terms. Let me give you 2 examples. One of that, and we're going to look at one where there's addition and subtraction, and we're going to look at one where there's division and multiplication. So if I had something like 5x plus 3 minus 2 equaling, I think I'll make my life easy, make it 11. Okay, so I have subtraction and addition. I can choose, I can elect to deal with each one of those individually. Or I could choose to just do the combined like terms. So let me show you both of those possibilities. So I could say, hey, there's some subtraction, so instead of -2, I'm going to add 2. Then I have some addition, so instead of +3, I'm going to subtract 3. And now I see the division, so I see multiplication, excuse me, so I'm going to divide. And the nice thing is, you can use this as either this is what I'm supposed to be doing and this is when I do it, or this is what I'm seeing and this is when I deal with it. And either way, it works just fine. But you can see that it really translates to a 3-step equation because I did 1, 2, 3 steps. The alternative would be to combine the like terms. And you can only do that if they're on the same side of the equal sign as one another. But if they are, you can just see that, hey, that's just +3 minus 2. That means I'm left with +1. And now I subtract 1. And you can see I end up with exactly the same as I did right above it. And I can finish it by dividing by 5. I get exactly the same answer. So there is some flexibility in how you approach these problems, what order you do things in. Okay? Remember, subtraction and addition are exactly the same. Remember, we can change one into the other with that queso. Division and multiplication are the same thing. We can change one into the other. We're going to see that one in just a moment as well. But this is not necessarily super duper rigid, but it is really good. If you just get used to, hey, I can do this every time, then you start to realize where's the flexibility lie. Okay, there's a way to there's almost always a way to get around. It's like, here's a rule, and here's how you get around it. Okay, we're not getting around anything right now, but we could. And when we get to the point where we need to, that's what you'll do. Okay, and the better you get at doing this, the easier it will be to realize what the shortcut is or what the workaround is. Okay, that's the thing I always find that students need to know. You got to know the long way to appreciate the shortcut and to see why it works. Sometimes if someone shows you a shortcut, it's hard when you get lost from the shortcut. You go, I don't understand what's going on. This always worked before. Why isn't it working now? So that's one of the reasons why I'm always a big fan of the long way. So this again, look at how elaborate my setup is, how much work I have to show. There's no shortcut through this. Okay? There might be ways to work around things. Like I said, you could do this and this, or you could do it this way. There's ways to do it in a different fashion, but you still got to show every step. Okay? So I wanted to show you one more that involved, so that was a problem that had both addition and subtraction in it. What if we had one that had both multiplication and division in it? Like, let's say, how about 2/3 x plus 1 equals 9. Okay, so it's a fraction, but really, fractions don't upset me as much as they do other people. I mean, I don't like them, granted, most people don't like them, but a lot of people really hate them. I'm not that bad. But I still go through my little checklist here. I don't have any distributive property, there's no like terms. I have to deal with the addition by subtracting 1 from both sides. And this is where things get flexible, I guess is the word I want to use here. Now, you might remember back from our lesson on proportions that I could cross multiply, make a little butterfly, okay? But I could also see this as two completely separate and individual operations and deal with them one at a time. Because this x is being, maybe I should move it up here, because it's on the top. If you ever see it on the side, it's actually always on the top. If it's in the bottom, it has to be written there, and you'll see that in a couple of years, not right now. But this is, if I put my little dot there, we are multiplying by 2, and we are dividing by 3. So there are two things going on. That's what it means to multiply by 2/3. Multiply by 2, divide by 3. Well, we can undo both of those by doing their opposites one at a time. So I see division, that means I'm going to multiply. When I multiply by the denominator, I get 2x equals 24, because these can be reduced. Now I'm on to multiplication. I multiply by 2, so I'm dividing by 2. and I took a fraction and I turned it into 2 steps. It really was 2 steps almost no matter how I did it. If I had done the cross multiply, I would have gotten the same result. I would have gotten here, 2x equals 24, because there's a 1 here. When I multiply this, I get 2x. When I multiply this, I get 24. So I can break it down, okay? Or really, I could have just, when I got to here, I could have multiplied by the reciprocal. Remember, division is the same thing as multiplying by the opposite, the reciprocal. So instead of trying to divide by 2/3, I could have multiplied by 3/2. That's why they think of this as kind of 1 step, but I always think of it as 2, because they're 2 very distinct things that are about to happen. Even when you work it out in your mind, even if you know, hey, it's 1 step, but when you do the math, you're going to go 3 times 8 is 24, divided by 2 is 12. You're not going to do like an 8 times 3/2. It's not like, and like a boof. You're going to break it down into 2 pieces. And that's why this is another way you could end up with 2 steps. And there is a way that if we put this together with that, I could probably throw a 5 or 6 step problem at you right now, and it wouldn't be that much more challenging, just because there's so much. You just have to make sure, one, that we're doing them in the right order. That's one of the biggest components that this whole section on solving multi-step equations is all about, is making sure you do things in the right order. If you do things out of order, you're going to find yourself with, well, one, wrong answers almost every time, or you're just going to get lost because you can't be consistent from problem to problem because you're doing them differently when you don't follow this nice, neat, step-by-step guide. And obviously, we can throw an exponent in here at the end, okay, because that's the last thing we're going to deal with. So right now, we're not dealing with it, but it'd be right here. We could add an exponent to this and add one more step to this process without a whole lot of difficulty, but we'll do that after we've talked about square roots a little bit more, which we haven't done at the moment. So this would be solving 3-step equations. So there's you've got 3 possibilities that could make it a 3-step equation. One is that we have a parentheses and we have to do the distributive property. The second would be that we have some like terms that need to be combined before we begin. And if they're the variables, then it has to be done first. It has to be done before you can do the rest of this. Not before the distributive property, but before the rest of the adding and subtracting. And then there's the possibility that adding and subtracting are both present, or multiplying and dividing are both present, in which case we would have a 2-step part just to that little section. So really this is like 1 here, 1 here, could be 1 or 2 here, could be 1 or 2 here. So you can see very quickly how we might get to 6 steps very easily if you had this, 2 of these, and 2 of those. Okay, and heaven forbid we threw an exponent at you, I could throw you a 7-step equation this year. Right now we're at 3. So again, now we're starting to get where it's complicated. This is where showing your work becomes ever so important, critical even, vital. Show your work on every single problem, okay? If it ever asks for mental math, you just say, forget mental math, here's me showing my work. Here's how it gets done. Because if you do that, when you make that occasional mistake, it'll be much, much easier for you to find the mistake and fix it, okay? And same for other people. If you say, hey, what did I do wrong? You always want someone to be able to go, it's right there, I can see it. And if you don't have your work shown, then they're just going to look and go, well, I have no idea. There's just a wrong answer. Okay, so again, step by step, okay, show your work, and I will see you guys eventually.